Hello, my name is Sophia Willows, and for my honours project I worked on producing a Māori language grammar checker under the supervision of Taka Keegan. I'd like to thank the folks at Te Reo Media for donating some of their language technology to us, in particular their chief linguist Eva Finn. She was incredibly helpful during this project, and I'd also like to thank Dr. Peter Keegan from University of Auckland. He maintains a website called MāoriLanguage.info, which contains a wealth of information about Te Reo. So Te Reo is the indigenous language of New Zealand, and it is one of about 2,500 languages which are endangered. The Māori people had an incredibly negative experience with colonisation, and one of the ongoing effects of that has been the decline of their language to such an extent that it's actually in danger of going extinct. And this is a problem because the world loses a little bit of its richness and diversity whenever a language goes extinct, and it also means we lose access to all of the content which exists in that language, assuming it hasn't been translated ahead of time. There is a ton of culture, knowledge, and history embedded within Te Reo, and it could all end up disappearing without revitalisation of the language. An example of useful information in Māori text is manuka honey, which was used for hundreds of years by Māori people for medicinal purposes. We know now that manuka honey does in fact have antimicrobial and antibacterial properties, and there's presumably a ton of information like this out there which we could use if we were able to process all of the text that's out there. One of the ways you can preserve or revitalise a language is through building capabilities for computers to understand that language, so things like digital assistants such as Siri or grammar checkers. Languages like Māori have very few of these facilities built out, predominantly due to a lack of data. And so what we've tried to do as part of this project is build a grammar checker for Māori in order to see if it's possible to do given the current constraints around data. This is at a high level a 4-step process. The first step is to acquire a bunch of Māori language text. The second step is to then prepare that text so that it can be consumed by a computer. So this involves things like stripping out formatting, removing bullet points from bodies of text, because bullet points grammatically function a lot differently from regular paragraphs, things of this nature. The third step is to then acquire examples of incorrect Māori text, so these are sentences with grammatical errors, because we want our computer to be able to learn from both good Māori sentences and incorrect Māori sentences. And the final step is to train and evaluate our grammar checking model. So step 1, there's a decent amount of text out there on the internet, a lot of which is available under a permissive license. We've also been able to use some text from the university. Here's an example of a Māori Wikipedia article. Māori Wikipedia is surprisingly good. There are macrons, the formatting's reasonably minimal, and there are off-the-shelf tools available for processing it. The key thing here is that a lot of these articles have English mixed in, which we don't want. Some of our other text sources were quite a bit messier than Wikipedia. We then had to generate invalid sentences, so we do this by taking bits of text from our corpus and applying some transforms through scripts. So one example of a transform is Māori's verb subject object language, so you'd say like roughly ate I an apple instead of I ate an apple. So one of our transforms is to swap the order of a verb and noun in a sentence in order to simulate a language learner mucking up the order of the words. We then trained the AI model and we've tested a couple of approaches. Our results weren't particularly good, which is actually what we expected, because there isn't a lot of sort of pre-existing technology you can build off of. We had about 50% accuracy with our AI model and between 50 and 65% on our baseline checker, depending on parameters. but we're hopeful that in future people can build upon the work that we've done and get a little bit closer to a functional system with better models, more data, and a better validation set.